Okay, I'm doing slightly optimistic 38 slides. I'm rushing pretty quickly though. A lot of them are just nice, pretty maps and pictures. So I'm going to be talking about studying the data that we can mine from bicycle sharing systems, which are a new phenomenon that's sort of swooping around the world. And they're proving to be a very interesting source of data for looking into transport flows in general, and more specifically how cycle commuters and motorcyclists move around cities. So, what is bicycle sharing? We don't have a system here in Edinburgh, but we do have one in London, so some of you may be familiar with a bicycle sharing system. Basically, you hire a bike from a docking station, which is typically automated, feature controlled, and therefore a good source of data. You ride the bike for a short amount of time, and the pricing structure generally tries to dictate that you only cycle for short periods, and then effectively hand the bike back to another docking station into a journey, and then somebody else can use the same bike. So in theory, bikes can be used multiple times in a single day, and from that you can have quite good usage from a small number of bikes. Bikes are generally pretty custom made to prevent people removing wheels to add to their own collection, and they're normally pretty solidly built. Does anyone recognise where this photograph on the right is taken from? Just to confuse things, I've got a Barclays cycle hire from London and a Melbourne bike as well in the same photograph. It's actually Vancouver, underneath the Lionsgate Bridge. So, unfortunately, cycle helmets are compulsory in Vancouver, which is why I'm wearing them. So there is value in studying bicycle sharing flows. Three groups are potentially interested: academic researchers. We can discover characteristics of the city itself based on how people use the bike share systems. We can also integrate cycle sharing data with other forms of transportation to add effectively a new node into a multimodal transport system. System operators, that's people who run the bike shares, they're interested in potentially seeing what would happen if they extended the scheme or if they interrupted one, such as for the Diamond Jubilee in London. Quite a lot of the docking station in London was switched off, and that would presumably have an impact on how the scheme operated. And also redistribution, which is a task where the operator has to put bikes back to where they're needed and where they are. City authorities are also interested in looking at how successful schemes are, and the success of schemes vary depending on various characteristics. And finally, working out who is using bikes and what for, so they can plan appropriately for each city. The data that I'm basically looking at for this paper is mainly so-called docking station data. From that you can work out the area of the city that the system covers. You can see how intraday variations change, how it changes between weekdays and weekends, and also seasonal variations and access quality and field. Those are not factors that I'm currently including in my classification that I'll introduce in a bit, but potentially could be added to it. But the size of the city as well, so in other words, does the scheme cover the whole city or just a little bit of it? And also finally, unique geographical factors of the city, such as big hills, mountains, rivers and seas, which can obviously affect how people move around the city. So there's two main data sources which we looked at in this paper. There's the docking stations, those are the things where you dock the bike, and finally there's actual journeys. Now, we can collect docking station data ourselves in near real time, so every 2 to 3 minutes we collect the current number of bikes available in each docking station. But also some system operators for some cities around the world provide journey data, and this of course allows origin-destination graphs and matrices to be created and gives you a richer set of information. And at the end of this presentation we're going to briefly touch on the journey data, but I'm going to focus mainly on the docking station data. Been collecting quite a lot of data now, 1.42 billion records, 56 gigabytes, and the database is growing rather large, so we're going to ask system needs new hard disks to store this data, but we just keep finding new cities to add. Even this morning I got an email from Kansas City, which just launched a new scheme a couple of days ago. So yeah, how we get the data from docking stations? Well, typically it's just going to the web page that is associated with these, and basically scraping the information from their Google map, which we almost inevitably have. But in a couple of cases we can effectively hack the mobile phone, the iPhone apps that some of these schemes have. Hangzhou in China is the world's largest scheme, but there's no map, there's no website as such. But there is an iPhone app, and from that we're able to work out the extent of the scheme. Some operators actually provide proper ways to access the data, and there's actually a few third parties that also provide information as well. So as I say, we typically collect this data every 2 to 3 minutes, which is pretty rapid. It's 24 hours a day, 7 days a week. Sometimes, in the case of, for instance, Paris, you need to request each individual docking station its information. And in Paris, there's several thousand docking stations, so in order to prevent us from overwhelming their web server, we typically wait 10 to 20 minutes before doing a complete collect. And we basically get the location, the size, and the number of bytes of the docking station. So it's pretty simple data, but there's a lot of it, and there's still lots of interesting things we can do with it. So the journey data, typically the operators make available an Excel file containing all the journeys. So far, London, Washington DC, and Minneapolis are the 3 cities that are providing all this information. Boston provided a small sample of information for the competition. And quite excitingly, New York, which is going to be one of the world's largest schemes when it launches later this summer, specifically, when they were looking for operators, they outlined that the data must be supplied to people who want to do interesting things with it, which is great. And sometimes these come with user demographics as well. In the case of Minneapolis, postcodes of all registered users are included in the information. So let's focus on the docking station data, and let's tell the story by going around a few of the, I think there's 450 odd schemes around the world. We'll look at just a few of those and see what we can tell about the city and about its users and commuters simply based on the bike sharing data. Most of the maps are going to be at the same scale, so you can compare the size of the schemes by looking at the maps, except for this Hangzhou, which is just so huge you can put it on a slide, so I've shrunk it down. And these are all basically screenshots of the live version on the website, which is bikes.overbrand.com. I use OpenStreetMap as a background map, just to provide a different perspective. And each docking station is shown by a circle. Blue means it's empty at the time that I took the screenshot. Red means it's full, and you'll see there's significant spatial clustering in many of the cities. And generally I accompany them with 2 graphs showing the number of bikes available, and many schemes show a characteristic dip during the peak commuter hours. And actually that's one particular piece of interesting information we can collect effectively how long each day people work based on when you see the times of 2 dips. And there's some interesting results that come out from that. And I also include a weekend graph as well. So here's Paris, start with one of the biggest in the world. This is the biggest scheme outside of China. Only just fits onto this screen. Here's the 2 graphs. So this is a weekday graph. So you can basically see a drop at, I've got the times here, 9 o'clock in the morning and 6:30 in the evening. This is just a sample, but in general I've tried to pick days which are representative of the scheme in general. And then during the weekend you generally have a dip in availability, that is, usage of the bikes is very high when this drops. About sort of 3 or 4 o'clock in the afternoon. Paris is quite interesting because the operator, JC Dassault, actually has a barge which goes up and down the Seine. What it does is it collects broken bikes from one end, fixes them on the barge as it's travelling up the Seine, and then basically it drops the bikes off where they need it once they're fixed, which is quite innovative. I'm not sure if the same approach would work in London or not. Here's another French scheme, Lyon. It's one of the oldest systems, and it has a characteristic which is often happens in successful schemes, where in the middle of the city you have maybe one docking station every 50 metres, and then at the outskirts of the city they're much more spaced out, and that system works kind of well with both commuters and leisure users. Here's another one in Nice. Unfortunately I don't have any technical data for Nice because they recently changed their website, but I just quite like the way the shape of the Nice scheme is very different to the others because it has this coastal road. You have a hilly interior where you wouldn't cycle up and down into the hills, but you also have the core city structure there. Brussels is quite surprising. Its usage is quite low. Now, although they have had awful weather, even in days of good weather, it's difficult to see the traditional commuter pattern that you see in other cities. But the weekend usage is always quite big. And I think perhaps the reason why Brussels is a relatively unpopular scheme is because it's not compact, its density is quite low. If you compare that with Milan, again, both cities are quite big, but Milan is a much more compact scheme. And I think these schemes do generally work better when they're concentrated into the city centre. And sure enough, in Milan you've got the characteristic 9:15 and 6 o'clock peaks when the commuters are mainly using the systems. And again, in the weekend you have this characteristic big curve in the afternoons. Here's London. This is where the data collection started a couple of years ago. London is very popular, heavily used. Again, you see those characteristic peaks, same as the other European systems are shown apart from Brussels. We don't quite stretch Olympic Park, unfortunately, but we have recently extended into Canary Wharf. Canary Wharf sort of acts like a sort of second city centre to London. And this snapshot, which was taken after working hours, basically shows that central London apart from that one for some reason, they're pretty much empty, no bikes at all. They're all based on the edges of the system. And this is a pattern we see time after time, except if it's raining heavily. Compare London to Blackwall. In terms of its spatial extent, it's almost as big, but very different look. All the docking stations are quite small circles. They're all very spaced out, and they're all mainly along the promenade. And I think this one's very much set up to cater to tourists rather than to commuters. And the problem is you've got the trams as well, which I suspect most tourists would prefer to get. So you unfortunately don't really see much usage of the scheme in Blackwall at all. Barcelona is a lot like London, in that in this particular case I took the screenshot during the working day. So in the residential bit on the west, there's pretty much no bikes at all. They're all down on the waterfront in the commercial part of Barcelona. Barcelona is on quite a pronounced hill as well, so you generally get morning usage going down the hill, and in the evening people generally take up usage going back again, which gives the operators a real headache in terms of redistribution. Of course, being Spain, they have a different working day to the rest of Europe. In general, people go home for 3 or 4 hours at lunch, and then reappear at work at maybe 4 o'clock in the afternoon, and then leave work much later, and that's reflected in the